Hello, welcome back. Today we're going to finish up Chapter 2, and we're going to go over these topics. The define preprocessor directive, the number sign define preprocessor directive, is used to define essentially symbolic names with a value. And it's kind of like defining a variable constant, except that instead of it actually defining the variable as code, what this preprocessor directive does is tell the compiler that wherever it sees this, in this case pi, wherever it says capital P, capital I in your code, just essentially almost like a cut and paste operation, replace those characters with the characters 3.14159265. So it's not really a variable. It's just an instruction to the compiler to do a cut and paste operation. And it's useful because if we put this directive at the top of the program, and let's say we have multiple places throughout the program where we use pi. If we decided to change what we want to use for pi, let's say we want to add some more precision to it or reduce the precision, then we would only have to change it in one place by changing this define statement. So in a sense, it's a way of avoiding having to repeat ourselves. The define preprocessor directive is convenient because it's easier often also to read the to know what a number is or what a value is by looking at the mnemonic. Pi is easier to understand than 3.1415. And so another reason to use the define directive is because it makes your code easier to read. So you're highly encouraged to use define statements wherever you would normally use a literal value in your code, and put those at the top. And then in your code, rather than saying, for example, that the area of your circle is equal to 3.14159 times radius, the square of radius or power of radius of 2, it'd be easier to say that it's pi times the radius squared. So you use define directives when you can. By convention, we normally make our define constants or our identifiers for our define statements all caps, and we place them at the top of the file. And the other advantage, of course, is that define allows you to change one line of code rather than every time that value is used. So here's some examples of some define statements. Here, max is being defined as 100. File in is defined as double quote f colon data input dot dat double colon. And I read it that way because it's not really a string. You notice there's no type defined for our defines. It really is saying take this sequence of characters and replace it, compiler, wherever you see file underscore in located in my code. And then hourly rate is defined as 8.150. So it's also often easier to remember file in rather than typing this. And often file names can be quite long, and so it's easier to use your define statement so that when you use that file, you can use the shorter character sequence. Also, a lot of times we may change where our files are located, and by having this define statement at the top, it's easier to find the thing that you need to change where the file location is. So here's an example of using a define statement for pi at the top of our code. We're defining pi as 3.14159265. And then in our program in main, you can see here where we are declaring, where you're using pi in this formula. So we've declared a couple of doubles, circle and radius. Radius is being initialized to 5.0 in this declaration statement here. And the second line, we're saying circle area is going to equal to pi, the compiler will take this number here and replace it where pi is located. So this number here is going to be placed right there. And that number will be, and then those characters are actually going to be replaced there. And then the compiler will compile this line of code as 3.14159.265 times radius, which is a way of doing radius squared. And then here we have a cout statement that will output circle area after that calculation is made. So where should the define statement be located in your program? At the top of the program, or anywhere in the program where you declare where you would declare any other variable? Pause and think about the answer, and then hit continue. So it's going to be at the top of the program, and the reason is that we're often using the define statement to make it easier to modify things in the code without having to dig into the code later on. Another way we can declare constants is with the constant modifier. And in this case, we're actually modifying a variable to be a constant. And so the form is you use the keyword constant, and then the rest is a normal variable declaration with a data type and a variable name. And then if you need to initialize your constants. So you can do one assignment operation into a constant, and from then on, that constant can never be changed. So here's an example. We have the keyword constant. We're declaring this variable as a double. It's a constant variable. And once we do this assignment, 7.1111, x can never have another assignment operation. It will only ever be 7.1111. And so here, in this instance, we are using constant to define pi, and often we will, normally we will define our constant variables also to be all caps, so that we know that that's not a value that will ever change and that you can't assign into it. And so here we have the same operation. It works the same from here on out. The difference is that this is actually not being done by the process or by the compiler, but will be done within the code itself. Functionally, you don't really see much of a difference as a programmer, but if you're really just talking about wanting to have a convenient way to change variable values, then probably the define statement makes more sense. If you want something to actually be a constant, then if you want to use something more as a variable, then it makes more sense to declare it as a constant variable. So where should constant statements be located in your program? At the top or anywhere where you would declare other variables? So think about the answer, pause, and then hit continue. Well, in this case, you can place it anywhere in the program. Typically, you want these at the top of the function where you're using that constant. So it is more in this area, anywhere you want, but definitely at the top of that function. Sometimes we will enter a situation where we will want to be able to take a variable of one type and then cast it into a different format before we assign it into another type and into another variable. And so in C++, we can use something called the static cast function to do that. And the way the static cast works is you use the word static cast, and then in these angle braces here, this less than or greater than symbol, in here we identify what type we want to cast this value to. So whatever type this is, this value will be cast into that, and that will be the output of this function. And then you would presumably store that using an assignment statement into another variable. So here's an example of static cast. We have 2.0, and the static cast will take this. Of course, this literal written in this format with just a decimal point will be will be a double. And so if we want this to be a float, we can explicitly cast it into a float by using this static cast. And this will take this double, convert it to a float, and store it in the R. Characters, as we know, underlying a character is a number. And this is something that you may need to do on periodically, is take this char, which we know we represent by using single quotes, and if we want to get the actual numeric value of the letter B, it will store it in and store it into a variable. Then the way we can do that is, and we want to store it in an integer so that we can use it as a number. The way we can do that is we can use static cast. So here we're taking this letter variable, which has B in it, and then it will convert it to an int and store it in a number. So the question then is, what actually ends up being a number? Well, there's a chart that you can obtain at ASCIItable.com, and every character corresponds to a number. So capital B, we can see here, corresponds to the decimal number 11. They also give it to you in octal, but B basically is represented numerically as 11. And you can see, if you remember that let me correct that. That's the character B is actually over here. So B is represented as 66. And if you remember that capital A is 65, lowercase a is 97, and space is 32, you know, they're all sequential, so you could, remembering those three numbers, you can remember most of the characters you need to figure out what they'll be numerically. So capital A is 65, lowercase a is 97, and you can see that there's also other symbols which are represented as numbers. And so the ASCII code is just the numeric code that corresponds to the character. And that's what this will introduce here. So this value will be 66. So write the code to cast the float 3.5f to an int. And the f tells the compiler that 3.5 is a float. So, you know, if you just put 3.5, the compiler is going to read that as a double. But if you put the character f after it, and that can be upper or lowercase, that will tell the compiler that that is a floating point variable. So write the code to cast that into an int. And I pause, think about your response or write it down, and then hit continue. So we have 3.5, and then the function we're going to use is this static cast. And we need to tell the compiler what we want to convert the number to. And so we use these angle braces, and in this case we want to cast that into a double. So we'll put the type in the less than and greater than symbols, or the angle braces is the way I'm going to call it. And so static cast double, and then we're in parentheses we're going to pass in as a parameter the number we want to convert. So we'll put 3.5, and to make sure that that literal is interpreted as a floating point number, we'll put f, and then we'll use the assignment operator to pass that into a variable. So, you know, we'll need some kind of a float. And so and then of course we need a semicolon. So we're going to use static cast double 3.5f into a double, and then it'll be stored in num. And what this will do is, you know, actually this needs to be a double. So let me fix that. because we're casting it into a double. So we're creating a variable that's a double, which is what we're going to store this value in. And this conversion will take a floating point number, convert it into a double, and then we'll store it in this variable that's a double. So that's how we can do this casting. So constants and the ability to convert values are important skills you'll need as a programmer. Another skill you'll need is the ability to format your output. The first, we've used cout before, and we've used cout to just output, just regular characters, capital A through Z and lowercase a through Z and the space, maybe tabs. But, well, actually not tabs yet, because if we hit tab inside of our program, it'll just put a bunch of spaces in when we're just writing out our code. What we need to do is, if you want to use a special character that's not your A through Z, you need to use what's called an escape sequence. And an escape sequence uses a backslash. You'll notice all these backslashes. And so if you put \A, what you'll get is you'll get a beep. If you put \B, you'll get a backspace. \F is a form feed. \N, which we've probably seen already in some examples. This one you're going to use quite often, and what that does is it creates a new line. So when you create a string to output to the screen, if you put a \N, at that point the console will go to the next line before streaming the rest of the characters. And so you'll use that a lot. \R is return, and it often kind of does the same thing as new line. Depending on your operating system, some operating systems use \N, some use \R, some use both to do a character's return, and you'll see in files that there's a mishmash of that. Most programming languages will interpret both of those characters to be a new line, but for our programming purposes, use \N. Now, there's a problem if we use a backslash as the escape character, because what happens if we actually want to display a backslash? The way we solve that is use just 2 backslashes. And let's say that we want to use a single quote, a single double quote. Well, if we define this in a string, if we put a double quote inside of the string, what will happen is that will terminate the string, and then the compiler will be confused by the rest. So if you want a double quote to show up in your code, use a \, double quote. And then if you want a single quote, \, single quote, and then you can actually put a hexadecimal number, which we may go over later, or an octal number by putting a \, a number, and it will then use that ASCII chart. So if you go back to that ASCII chart, and we use the hexadecimal or octal code here, for capital A, it would be 101, for example. If you wanted maybe this shift character, you would use 016. If you put that in here, that would be the same as that would create that character for you. So that's a numeric way of creating the characters, and they would show up inside of your double quotes. So here we are creating a string. We're outputting how are you liking it. You see the \N creates a carriage return. So you can see there's an empty line here, and this creates this empty line here. And then here we have C++ Programming Today, 2nd edition. And why do we have that? Well, that \ escapes that double quote. If we didn't do that, the compiler would think that this is the string, and then it'd see this, and we would think this is a variable name. So we have to have this \ to do this, and that ends up being this character here. Again, another escaped double quote, so it shows up. And then we have this carriage return here. And then we have a double \ here. Why is that? Well, that double backslash allows us to see the backslash in the code right there. And then, of course, 2 more carriage returns. So that's how those backslash sequences are used, those escape sequences, and you'll need to use those to make your output. That's one way of formatting your output. So that shows a, that. So that backslash shows a double quote. This one allows a double quote to be seen. Here we're showing a slash, a backslash. Otherwise, that would put a carriage return. So if we don't want a carriage return, we want the backslash to show up. Another way we can format output is using iOS formatting flags. And you can think of them as switches. So when you set an iOS formatting flag, all text from then on will apply that rule. So, if you applied the left iOS flag, all your output would be left justified. You apply the right, all your output would be right justified. And there's several formatting flags which you can use. So there's some example programs. If you go to Blackboard, you'll see that we have book example code here. We want the chapter 2 code. So when you do that, it'll download the code. You'll get a zip file, and you can extract that zip file. And within here, we have a number of sample programs. So as you're reading the text and you want to look at the code, I recommend downloading the sample code and looking at it. So we're going to look at this program 2, which has the iOS flag. So open up a program. You'll double click on the SLN if you have to have Visual Studio installed on the machine which you're doing this. This is opening in 2017. You'll probably open up on 2015 depending on when you observe this video. And you might get this upgrade request because some of these programs were done quite a while ago. So go ahead and click OK to allow the Visual Studio to do the upgrade. You might get a security warning because you downloaded it. And it might give you a migration report. And then here's your program. So very similar to when we built the Hello World application. And if we open up the source file, we'll see what the code is. And here we have some examples of iOS flags. So in order to use the iOS flags, we have to include the the IO manip library. We've been using IO stream library for cout. But the IO manip library allows us to do some formatting. And the commands that it provides us include the following. So here we have some couts. We're outputting some text. You can see the backslash and making a carriage return. And then one of the commands we can now use is set precision. And by setting precision, that means all floating point numbers from here on out will show 5 points of precision. And to demonstrate that, we'll have some code here. We can also use the setF function. The setF function is an iOS function which allows us to use an iOS flag. And to use an iOS flag, you put iOS : and then whatever flag you want. So in our PowerPoint, we saw, here's the list of all the iOS flags. To set any of these flags, we use iOS show point. And then from then on, we will have our numbers displayed with 5 points of precision and with a decimal point. And so I'm going to run this. To run this program, I'm going to go to debug, and I'm going to start without debugging. And when we can see with this code, when we run it, here we have this. The first thing it did is up here, it just wrote everything without any flags set to show you what the numbers look like by default. When we set precision 5 and show point, what we got was 5 points of precision. And the way you get the precision is it's the digits. So 1, 2, 3, 4, 5. Even though the decimal point's at 4, we got 5 points of precision here. Here, because 528 only provides us 4 numbers, we need to add a 0.0 to make that 5 points of precision. Our 1, 2, 3, 4, 5, 7 has too many numbers, so it goes to get 4 points. To get 5 points of precision, it gives us 123.4, and then it rounds the remaining numbers to only give us 5 points. So precision is the number of digits that are available. Here, we're adding another iOS flag, and we're setting iOS fixed. And what that does is says we want the precision is really specifying everything after the decimal point. So now we can see that pi is 3.14159 rather than stopping at the 6. It gives us 5 points of precision after the decimal point. And then here we have 5 zeros after the decimal point. So in all these numbers here, we see that we're getting 5 points after the decimal point. So often, in order to display your numbers with the precision you want, you're doing a precision, a show point, and a fixed in order to make sure that you get the number of points. So, if you want 2 points of precision, you'd say set 2 points of precision, set F iOS show point, and set F iOS fixed, so that all your numbers would, from then on, display. To unset a flag, you would use unset F, and that would unset the flag. So you can set the flag with set F and unset the flag with unset F. There's other things you can do. When you include the iomanip library, you can use a function called setW. SetW sets a field width for the variable output. So if you say cout the value of x is and setW 5, it'll display x, but it'll always use 5 spaces to display x. And that can be useful when you're trying to create a program where you're displaying numbers in columns. And the string class itself. So a class you can think of as a job description. And there are it's a way of combining a bunch of functions which apply to a particular type, usually a user-defined type, but also types that are defined in the library. So the string class, all these things we've been writing, for example, when we wrote hello world with double quotes around it, those are strings. The string class has some functions which work only on strings. And the way we use them is if you declare a variable and assign something to that variable. For example, here we have Albuquerque Isotopes being assigned into the baseball team and Orbit being assigned into the variable team mascot. If you put a dot after that variable, you get access to some functions which apply only to strings. So in this case, size is a string function which tells you how many characters are in there. And so if you did this, size would return the number 20 because there's 20 characters in Albuquerque Isotopes. Don't forget the space. And then if mascot dot size would be orbit. That's 5 characters. So it would assign the value 5 would be assigned into here, and 20 would be assigned into team size. The string class also has a function called find. And again, we have to use the dot operator to get access to the find function because it only belongs to strings. And so to make sure that the compiler only uses that function with strings, we have to use it on a string. So here team is a string. And so if we want to find the nickname in that string, the find function, if we pass a string in here, it'll look for the position of that inside of here. So Topes is here, and so where will it display? And Topes is going to be, so all your sequences will start with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, should be something like 15. So that would return the value 15 would be placed into location. And if it doesn't find it, the find function will return a result of -1. So if you were, and the nice thing is that in Visual Studio, if you put the dot operator in wait, it'll give you a list of all the functions, all the methods which are available for whatever type this is. So sentence, we can see, is a string. So because it's a string, we're going to get all the string functions when we put a dot next to that function, next to that variable. So at this point, I recommend you complete the formatting in strings demo. And then the debugger demo. So if you look at Appendix 1 of your book, you'll see instructions for how to use the debugger. It's very important for you to go through. That will make it easier for you to write your code and find where the problems are. Thank you very much.